Hello, everybody. Okay, that's horrible. Let's not do that. I should play with this when I'm not trying to work with you guys. I never think about it at the time. I need to take the time to get good at this. Okay. Hello, everybody. This is Mr. Sexton, everybody's favorite math teacher. I need to talk to you today about something that we haven't actually done before. This is going to be relatively new. We're going to talk about the volume of a shape like this, yikes, like this one. What we have here, it's definitely a 3D shape, but it's not really a 3D, it's not really a prism, is it? It's not a rectangular prism because it's got a shape on the top. And if you look down here where this shape would be, let's see, I need to make that black. If you look down here where this shape would be, down here on the bottom, it would be, come on, you can do it. It would be something like that. Down here on the bottom, it's much bigger than this up here on the top. So we can't use our volume formula of length times width times height to find the total volume of this entire shape. But if you look closely, a lot of you have probably already noticed that it's not just a random shape, it's actually made out of two pieces. There's this piece here. It's this piece here. You see that? And then there's this other piece that's down here. It's this part down here, right? That's a whole other piece. While this is not altogether a rectangular prism, it's made up of two rectangular prisms. And if I break this into two pieces, I can find out if I call this piece A, and I call this down here piece, let me get some hotkeys or something to change these colors if I'm going to use this. I can call this down here prism B. You see what I'm talking about? This is one prism, this thin, skinny one laying here on top. I'm going to call that A, and I'm going to call this big fat one on the bottom, I'm going to call that prism B. Now, I can call this one B and this one A. It doesn't matter. I just like to start from the top because I'm boring that way. But what matters is that I see that it's actually two pieces. And I'm going to imagine for a moment that I've taken a knife and I've cut this little piece loose so that I've got two pieces, this little piece and this top piece. If I do that, then this little piece on top, let's see if I can try to have any better luck with straight lines. Then this little piece on top here, yeah, I like that a lot better. This little piece on top here, it is absolutely a prism. It's the same on the top and the bottom. So I should be able to calculate the volume of just this little piece up here. Now I'm still going to use the same formula I always used. I'm going to use length. Oh, I'm still in straight lines. I'm still going to use length times width times height equals volume. But we're going to have to do it two times. We'll do it once for this little piece and once for the big piece. So let's come up here. What I've done is I've set up this piece, this bit here. Do you see that? That is just a section for me to solve prism A. I'm going to do prism A up here. And then down here, that's not prism A. This one down here will be for prism B. Nicely done. Good save, Mr. Sexton. Okay, so for over here, I'm going to figure out the volume of just this little piece. And over here, I'm going to find the volume of just this big funky piece on the bottom. And then in the end, Spoiler alert, we're going to add them up at the end. Okay? So first of all, if I'm looking at just the length, which is, yeah, that's what I want. I'm looking at just this length of prism A. Those really should be red. I'll get this figured out just in time for us to come back together and be working together, and I don't need this anymore. Okay. If I find just the length of prism A, this top one's prism A, the length is going to be how long it is across here. Doesn't tell me exactly how long that line right there is, does it? But it does tell me how long this line is. You see that? That line is 18 centimeters. Well, if that is 18 centimeters, then this line right here that's 18 centimeters, isn't it? And then equally this line here, it's also going to be 18 centimeters. So I know it's 18 centimeters long all the way around. So my length is going to be my pencil, there it is. My length is going to be 18 centimeters. Now let's talk about units. This is 18 centimeters. A centimeter is a measurement in a straight line, right? That's not a volume. That's not an area. That's a straight line measurement. If I took a ruler from here to here, it would be 18 centimeters. So my length is 18 centimeters. It's not 18 centimeters squared. It's not 18 centimeters cubed. It's 1 centimeter, one instance of the centimeter. From here to there, that's just a centimeter. Okay? Now for my width, I need to know how long it is this way, right? From there to there. Do you see that? But it doesn't tell me there, but all of these lines that are parallel to each other, that are part of this prism, have to be the same. So that means this line from here to here, that has to be, I like those lines. That has to be the same, this has to be the same, and this has to be the same. So on any of those lines are the same, actually we also know that this one here is the same, isn't it? Of any of those four widths, are any of those labeled? Not here, not here. This 2 centimeters is for the up and down, isn't it? It's next to that line. Look, 3 centimeters right there. That's the one I need. So my width is, my width is 3 centimeters. Heavy sigh. Centimeters. Okay? Not 13. It's 3 centimeters because it's the same as that. Now my height, that's just how tall it is. Again, any of those lines that are part of prism A and are parallel to each other, let's go with purple. So that means that this line, this line, this line, and this line all have to be the same height. So you can look and see if any of those lines have a measurement, and we do right there. So that means it is 2 centimeters high. My height is 2 centimeters. Okay? Now I need to find the total volume of prism A. I'm just going to use my formula. My formula, remember, is length times width times height equals volume. So my length is 18. My width is 3. And my height is 2. So my volume is going to be equal to 18 centimeters times 3 centimeters times 2 centimeters. And that'll give me my volume in centimeters cubed. Centimeters to the third, that's centimeters times centimeters times centimeters. We call that centimeters cubed, right? So now we get to do some math. That's the best part, isn't it? Let's come down here. 18 times 3. What's 8 times 3, guys? Yes? I hear you there in the back. 8 times 3, yes, it is 18. No, it's not. It's 24. Thank you for correcting me. 3 times 1 plus 2, that's 5. So 18 times 3 is 54 times 2. Well, let's see. 54 times 2 is 2 times 4 is 8. 2 times 5 is 10. So I get 108 centimeters. It's not centimeters straight line. It's not just centimeters. It's not 108 centimeters in a straight line. You can take a ruler. You will not find 108 centimeters on any single feature of this. It's not centimeters squared because that would be how many 1 centimeter squares it would take to tile in the surface of this. You see that? That would be if we covered it over in these little squares, which we're not doing, right? It's centimeters cubed because it's centimeters, because it's a centimeter times a centimeter times a centimeter equals centimeters cubed. That means centimeter times centimeter times centimeter. So my total volume of Prism A is 108 centimeters cubed, right? And I'm going to circle my answer because I know Mr. Sexton likes that. Okay. Now, let's talk about Prism B. Prism B, we're going to do the exact same thing. Same, second verse, same as the first. We're going to find the length, width, and height of Prism B. Well, let's see. Let's start with length. If I'm going to talk about length, then let's go with yellow. I like to call the longest run the length. Some of you heard me talk about this for length and width. If I called this length and I called this width, I'd still get the right answer because 7 times 21 is the same as 21 times 7. It doesn't matter. But the height, I need you to get in the habit of paying attention to the height. The height is how high it is off the table, how tall it is. There's a lot of stuff you're going to do at Dempsey where you're going to have to know what the height is. It's how tall the figure is. So I like to call the length the longest one. But if you called this the length and this the width, it's still going to work out just fine. It's tomatoes, tomatoes, right? So I'm going to call this my length. Boom. Which of course is the same length as all the other sides that run the same way as you go around the figure, right? And this one, it goes all the way back here. That is the same, and they're all 21 centimeters. They're all 21 centimeters, not centimeters squared, not centimeters cubed, just plain Jane, good old centimeters. I can measure that with a ruler. Okay? Now I need to know my width. What color should the width be? Let's make the width purple. I'm in a purple mood today. The width is just the other direction, which means it's going to be from, I like those lines. I like the result when I take the time to do the lines. So I should do that. If I take that there, that is a width, which of course is going to be exactly the same as every other corner on this thing that's going the same way. That's going to be the width of that. It's going to be the width of that. All those purple lines, all those sides that are the same, they're all 7 centimeters, not just this one. Okay? Now either way you slice it, my width is 7 regular old centimeters. Now I've got to get my height. What do we feel like for height? Don't have enough colors in this thing. Oh, here we go. Now we can get bright. Let's go with dark green. How about that? That'll be nice. All right. So the height is always how far it is up and down. That means this one, that means this one, that means this corner, and that means this corner. They're all going to be the same. Do you see that? So it doesn't matter which of these are labeled. If I know what the length of any of these are, I know what they all are. The green corners are 9 centimeters. By telling me that this side here is 9 centimeters, I also know that this one's 9 centimeters, this one's 9 centimeters, this one's 9 centimeters, right? So I know that they are all, the height all the way around for this figure is 9 centimeters, okay? Now I have my length, width, and height. I can figure the total volume of prism B, Mr. Sexton. That is prism B. If I didn't have some mistakes built in here, you guys wouldn't know it was me. I just miss having you around to point them out to me, because otherwise I don't even notice them sometimes. All right, so I'm going to use my same formula, length times width times height. I know that length times width times height equals volume. My length is up here, 21. So my length is 21 centimeters. My width is going to be 7 centimeters times my height, 9 centimeters. Right? What is it doing? Somebody make it stop. Okay. This is going to be equal to my volume. So let's do some math. Let's clear a space over here. Goodbye, goodbye. Goodbye, Mr. Bond. All right. Let's come over here and do, let's start with 21 times 7. 21, I'm going to do 21, why not? 21 times 7. 21 times 7. Well, 1 times 7, that's just 7, and 7 times 2 is 14. So 21 times 7 is 147. Right? Now, 147 centimeters times 9 centimeters. Let's see, I need more space. Let's see, will this let me just move it down? Yeah, it will. Ooh, I like this toy. I like it. The better I get at it, the better I like it. A lot of stuff is like that, isn't it? Okay, so 147 times 9. Ooh, these are tricky. 9s help me out. 9 times 7, that's just, what is that, 63? And then 4 times 9. Well, that's going to be 36 plus 6. It's 42. Wait a minute, I lost my place. Yep, 42. 9 times 1 is 9, plus 4 is going to be 13. Wow, I get 1,323. So that means the volume of prism B is 1,323 centimeters. What are they? Shout it out so I can hear it. Come on, CJ, what is it? Centimeters cubed, right. So that is the volume of B. Now what I've done here is I've figured out that this one, volume, prism A, this is 108 centimeters cubed. And I've figured out that this, I need to be green, don't I? That this, B, is 1,323 centimeters. Glitch. Make it stop. Centimeters cubed. But the question is, what is the volume of the whole shape, right? This is what they want to know. So I know the volume of this part and this part. So what do I need to do? What do you think, Jakai? Don't make me draw a tape diagram. You know I will. We find the total by adding them up. So the volume of A plus the volume of B is going to be the volume of the whole thing. So that's going to give me 1,323 centimeters cubed. Now I'm going to take a moment and make sure I've copied my number the right way at all the places. It's an easy mistake to make. Even Mr. Sexton makes it sometimes. And I'm going to add to that the volume of the top cube, which is 108 centimeters cubed. So if I add them up, I get 8 plus 3, 8, 9, 10, 11. I got 2 plus 0, that's just 2. Oh, carry the 1, that's 3. Almost goofed that one up. And then 3 plus 1 is 4. And then 1. And I've got 1,431 centimeters cubed. Not centimeters sixes, not centimeters nines. We're adding. So the unit stays the same, right? All right. So my answer to this whole big monster of a problem is 1,431 centimeters cubed. That is a complete correct answer with the right unit. This is a full credit answer right here. Now, on today's assignment, you don't have to necessarily show me your work on this. Calculating is fine, but you're going to see that it looks an awful lot like this. You've got a shape, you've got a section to put in the details about Prism A, the details about Prism B, and then find the whole thing. In fact, I should be able to, hold on. That was scary. I wasn't sure what was going to happen. In fact, I should be able to just show you maybe. Oh, no, that's yesterday's. This is what you need to see today's. Today's is going to look like this. It's just like what we just did, guys. I got a large shape, and I've broken it into 2 pieces. You're going to find the length, width, and height of Prism A and the total volume of Prism A. Then you're going to find the length, width, and height of Prism B, the total volume of Prism A. And then you are going to add up the volume of A, add that plus the volume of B, and that will give you the total whole shape. I need to see units on this. Yesterday, a lot of you used the formula correct, but you were giving me the wrong units. If it's a volume, it's got to be a unit cubed. If you put just a unit, then that's not even close. 2 centimeters and 2 cubic centimeters are just as different as an inch and a gallon. They are not the same creature at all. So it's important that you give me the right unit. Okay? If you have any other questions, reach out to me. I'll be available for Google Hangout during office hours, and I hope to see you there. Thanks, guys.